Okay, in this video I'm going to talk about how to use the normal distribution to approximate the binomial distribution. And you can use normal probabilities in the appendix table, but first we have to do a few things. And these rules have to apply. N times P has to be greater than or equal to 5, and N times Q has to be greater than or equal to 5 in order for this to work. Now, why would we want to use the normal distribution instead of the binomial? Well, the main reason is that we have a table that we can go to that's really easy to use and easy to look up. And if you had to actually calculate the binomials, it can take a good deal of time. So let's look at a problem. According to a recent survey of all smartphone users, the survey was between the ages of 18 and 34. A random sample of 100 smartphone users was selected, and using the normal approximation to the binomial distribution, what is the probability that more than 34 people from this sample were between the ages of 18 and 34? So it's telling you to use the normal approximation to the binomial distribution. But if your sample size is large, a lot of times you can check it to see if you can use the normal distribution instead. So let me just show you how to do that, even though they're telling us that we can use it. We know that N is 100. We know that P is 0.39. So Q would have to be 1 minus 0.39. So Q is 0.61. So if we did 100 times 0.39, that would be 39, and we know that that one meets the requirement. Let's check the second one. 100, of course, times 0.61 is going to be greater than or equal to 5. So that one also meets the requirement. So that is how you check to see if you can use the normal distribution. So before we can use the normal distribution to get the z-score, remember the normal distribution, the z-score is x minus the mean divided by the standard deviation. So we have to know the standard deviation and the mean. So if you remember, for a binomial distribution, the formula for the mean is N times P, which would be 100 times 0.39. So the mean is 39.0 or 39. Now for the standard deviation of a binomial distribution, the formula is the square root of N times P times Q. So we know that N is 100, P is 0.39, and Q is 0.61. So if we take the square root of that, you will get 4.877. So now we have the standard deviation and we have the mean. Now we can find the z-score. And we're trying to find the probability that more than 34 people from this sample were between the ages of 18 and 34. Now, here's where it's a little bit different because we are approximating the binomial using the normal. So the difference here is we're going to have to use what's called a continuity correction factor. So I want to do a visual here. We know that the average, the mean we found was 39. And we know that we want more than 34 people, okay? So if we want more than 34 people, we don't want to include 34. And you only have to do this for this type of problem. So we're going to say more than 34 would be 35. So I'm going to draw 34, but really ours is going to start at 35, and we're going to be more than. So let's think about this. Do you have a left boundary? Yes, our left boundary is 35. Do you have a right boundary? You do not have a right boundary because it's going to continue on to infinity. So here is the rule. For left boundaries, you are going to subtract 0.5. And then for right boundaries, you're going to add 0.5. And I do believe it was, okay, we're going to work this a little bit different. We're going to change the problem here because I want it to be more like what's on the test. So let me see if I can do that. I'm going to pause it for a second. So I've changed this to 34 or more people. So we do want to include 34 in this now because it could be 34 or more. But since we have that correction factor when we're approximating, we have a left boundary. And if you have a left boundary, you're going to subtract 0.5. What if we would have had a right boundary? You're going to add 0.5. And this is just a correction factor, a continuity correction factor. Okay, so our value is going to be, for x, is going to be 34 minus 0.5. So x is now going to be 33.5. Okay, now if it was more than 34, then it would be 35 minus 0.5. Okay, so since we changed it, remember our z-score is x minus the mean divided by the standard deviation. So we know that x is now 33.5 minus your mean, which is 39, divided by your standard deviation, which is 4.877. So if you calculate that in your calculator, I want to say you're going to get negative 1.13. So now we have to go to our table and find negative 1.13. So negative 1.1, this is negative 1.10, 11, 12, 13. So 0.1292. So when we go and look at our table, 0.1292 would be this area here. Remember, if we want greater than, then we're going to have to say 1 minus that area. So we know this area is 0.1292. So the probability that x is more than 34, and the probability that z is more than negative 1.13 equals 1 minus 0.1292. So our probability is 8.8708. So this is specifically for when you're approximating the binomial distribution using the normal distribution. Let me know if you have any questions.